Hi guys, Scott here. For today, I'm working in my tiny upholstery shop, which right now is serving as a transmission shop. And I'm about to begin my build of a 4-speed automatic overdrive transmission to go in the 66 Econoline. Now, I'm basing this on a 1992 AOD, which was one of the last totally mechanical, non-electronic automatic transmissions. Very reliable, and with a few modifications, can be set up to handle over 1,000 horsepower. My old C4 has been pretty good, but not so much on the interstate. So for all you other Econoline guys, I hope this video helps you out if you want to go this route. And there's really tons and tons of information out there on building these. A lot of it is decades old with links that are no longer valid, and you have to sift through a lot of the stuff that's geared toward drag racing, which is not really what I'm building this for. I am going to do some towing, so I want to use heavy-duty components to make it good for that. But it's hard to kind of separate the racing stuff from just reliability stuff. Also, some excellent videos on YouTube that have helped me along the way. Just get prepared for this. And I hate to use the word expert. I'm certainly not a master, but all the studying I've had to do on this, now I can pretty much tell you what every part in this is called, and I know what it does. And so after I'm done with this, I could probably open a AOD transmission shop. So to start out with, I have this AOD that came with the 302 I bought that I installed in the van. And it was rebuilt, quote unquote, by a shop, I'm pretty sure, because it had this bracket here holding the torque converter in, which is kind of a mark of a professional, but they did not do a great job. They didn't replace any of the bushings, and a couple of them were pretty bad. But at least it's fairly clean and a good base for what I need to start. So that's what I have on this side. And then over here, I have the guts from a 2002 4R70W, which is a much heavier duty transmission. And most all of these parts will swap into this 92 transmission and has pretty much all the upgrades to make it almost bulletproof. Now, this transmission was electronically controlled. Now, you can use a 4R70W electronic transmission. They made them with small block bolt pattern, but then you need either a standalone controller to run it or a factory Ford ECU, but you have to give it the inputs it needs to operate successfully. Now, the standalones these days, it looks like they're $700 and up, so I didn't want to go that way, and I may in the future, but probably if I do, I'll use the Ford factory unit, go that way. I don't need to have 3 or 4 different shift patterns like the standalone units provide. They look really good, but it's a lot of money, and it's a little electronic box that, although unlikely, could go out in the middle of nowhere, and all the king's horses and all the king's men couldn't fix it. So I'd rather go with a Ford factory unit where I could grab a spare from the junkyard and test it and have it along just in case. And so basically, you'd have to fool the ECU into thinking it's operating the vehicle it came from. So you'd need a throttle position sensor. You'd need a speed sensor. You'd need an O2 sensor, RPM, temperature, maybe a couple of other things. Not that hard to do. And if you have a fuel injection system off of the car the ECU came from, it already has all that stuff. So that's going to be a great way to run your fuel injection and your transmission. Not that difficult. But the nice thing about this is all these heavy-duty components can go in this older AOD and make it a great mechanically controlled transmission. Simple, reliable. A couple of the gurus I found on YouTube. Nick's transmission, pretty current stuff where he goes over every aspect of doing this build and the hows and whys of each component and what to use. Also broader performance, and he's more of a laid-back guy, but he obviously knows what he's doing and explains a lot of this stuff too. And so today I'm going to begin by replacing all the bushings. I've got a bushing kit here. And then I'll start cleaning this stuff up. And then I'll start assembling the components I want to use. I'm not in a hurry to do this, so I'm going to order parts as I go and do more research. So I'm going to start here with the pump. And this is one component that has to be reused in an AOD. Now, I haven't checked the clearances of this pump yet, but there's no scoring at all on these gears or inside the housing, so I'm sure it's just fine. But I will check it just for posterity. And there are 2 bushings in this and the front seal. And they make some really nice dedicated bushing driver sets to remove and install all these. I've had really good luck with sockets, especially impact sockets. The only thing you really have to be careful of is if there's a big chamfer on it, it can jam. But, you know, I don't want to become a transmission shop, so I'm going to see if I can get through with this technique. A great idea would be to buy a cheap set of sockets and then just flush grind them all. Give them sharp corners. I usually use them backwards. But this one will not fit through. It's too small there. Gonna have to drop back and punt on this one. This did not work. Just couldn't get a good enough grip. So this is a broken input shaft from a small outboard. Got a pretty good edge on it there. Let's give that a go. Thank you very much. Make sure you check how these internal grooves are oriented. Some of them, I don't know if it would make any difference, but I'm going to do this the same way, just in case This pump housing bushing is one that needs to be installed a certain way. This oil groove should exit at the bottom on the inside so it doesn't put pressure on the seal. At the bottom so the resting lube can get into the bushing. And now you're supposed to stake this bushing on either side to keep it from spinning, but that thing's pressed in there pretty hard. If it's spinning, you got bigger problems. I'm going to do it anyway. Okay, so this is the direct clutch, and it's widely recognized as the weakest link in these transmissions, even in the later model 4R70Ws. For one, it's the smallest clutch pack in the transmission. The early ones only had 5 frictions and discs. The later ones have 6, and they went to these better high energy models that has the black compound instead of the tan stuff, and these are pretty good. These are the factory ones, and they're still in great shape. So it's pretty easy to put 7 in this clutch pack, or even 8. But the it has been reported that the thinner steels you have to go to in the 8-pack will overheat and warp. So I'm going to go with 7. Now, I just need to order slightly thinner steels and then machine this pressure plate, just the outer edge, to get my clearance, just like this is on the forward clutch. There's also 4 selective snap rings to fine-tune it if you can't get enough, but I can I can get pretty much where I need to go just machining this pressure plate. But that leaves a nice thick pressure plate instead of, like some people have suggested, you just use an extra steel as your pressure plate, but that's just too thin. Now this is the AOD direct clutch, and nothing really wrong with these. It's cast iron, and this is the later version, so it does have 6 frictions and can be modified to have 7. A little bit less room than there is in this one. The snap ring is further down, but you can machine this pressure plate and put 7 in here easy. The main issue with these are the splines. Now, the splines are about 1/4 of an inch down in here, whereas the splines in these start right at the top. And so what that does is that it allows the input shaft to go in a little bit too deep, and it actually has a hydraulic pressure on it, and they will wear the splines even, although this one's not really worn. But what that does is it lets the input shaft contact the output shaft right here, and you can see on this one where it's kind of shiny around the edge, so these two have been touching. And what that does is it blocks this lubrication port that feeds the planetary gears. No bueno. You can see a contact pattern on the input shaft as well. Now, they do make snap rings to keep that from going down, and that's a pretty good fix. Best thing to do is grind a notch out the side of this lube port, so even if they do touch, which isn't a big deal, the fluid can still get out. That's heavy. Probably the only time you'll see this bench clean. Every man should have a lathe. And I've got one, a really old, crude one, back in Indiana in my barn. But this one's really nice. Not very big, but it's big enough to turn the pressure plate for my direct clutch, and I can make and fix all kinds of things with this. Seal drivers, bearing drivers. I've been wanting one for a long time. And I've been able to do some things with this fabulous mid-century Craftsman drill press, but it just spins way too fast to try to do anything this big. But this actually has a captive chuck on it that doesn't fly off even using a big hole saw. Well, it doesn't have a lot of power at low speed, which doesn't shock me. And the cutter, at least this one that came with it, is not as sharp as these higher quality ones I bought that have the replaceable tips. Both are carbide, but I think this is a harder carbide. It's cutting much better. So now I'm finalizing the turning of this pressure plate to get my clearance, and it's pretty difficult, especially talking about 80 thousandths, to get feeler gauges in between here. So I've just been wedging a couple of razor blades and Allen key between the pressure plate and the first friction, and then taking readings with a dial caliper. Now, you need to mark one spot on the rim of this because it's pretty uneven. And then take several readings and see what your most consistent one is, because it's gonna vary by a few thousandths, even if you're just a little bit crooked. So take several readings, see what your the most consistent one is. You know, you can also run a straight edge across, which I did also, and measured off that until I got consistent results. So kind of time consuming, but I've got about 85 thousandths clearance. The factory outside spec is like 94, and that's with only 6 plates. So I'm gonna buzz 3 or 4 thousandths more off of this. From what I've read, it's better to be a little loose than a little tight for a street machine or a tow vehicle. All right, I got the clearance I wanted. The little lathe worked pretty good. The last cut or two, you want to feed it extra slow so you get a nice nice smooth finish. And that's ready to go. All right, guys, well, we're over 20 minutes now, so this is going to have to be a multi-parter. But there is quite a bit of ground we had to cover with this build, so I am going to do my best to pass along all the tips and tricks I learned on this build. Until next time, thanks for watching, and please subscribe so you don't miss part 2. Don't cost nothing.